Welcome back. This is an Aleks training video on knowing the subshells of an electron shell. The shells are the various periods on the periodic table. So the first shell would be the first period where you have hydrogen and helium. The next shell, the second one, is from lithium to neon, etc. So subshells are where electrons hang out inside that shell. And you can, it's kind of like a intermediate location. So you might have the United States, and then you might have Mississippi as one of the subshells, and then inside subshells you're going to have orbitals that could even be more specific. So you could have, say, a street, and then an apartment, and then a apartment building, and then apartments in that apartment building, and more specific where those electrons hang out, or where they're likely to be. So I'm going to just give you some information, and then the homework is a piece of cake easy. There are, on the periodic table of the elements that are known, okay, we made a lot of these, the ones that are white after uranium. Uranium's the last one you can dig out of the ground. Anything past uranium is actually made in a lab. But of the material we know about, there are about 118 types of matter. You are going to have subshells like this. Okay, you have an S subshell. So if you have one subshell, you're going to have an S subshell. Okay, the next subshell in order is a P. So if you have two subshells, you're going to have an S and a P. Okay, the third subshell is a D. So if you have three subshells, you're going to have an S, a P, and a D. The fourth subshell is an F. So if you have four subshells, you're going to have an S, a P, a D, and an F. There is the letter G, which is next, but we haven't even filled all of the F's in order to need a G. So there's no necessary for a G. A G is like, I guess, in 100 years, if we make another 20 elements, you're going to eventually run out of room in the F's and have to have a place for the G's, and that's why it's there. But for all practical purposes during our lifetime, this is all that we're going to need. Okay. Now you'll see later that there are orbitals, or places that electrons hang out. So there's one orbital in the S subshell, there's 3 orbitals in the P, there's 5 orbitals in the D, there's 7 orbitals in the F. Don't worry about that now because it's not asking for it. They're just saying what subshells are in each shell. So let me give you the easy. In the first shell, okay, so period 1, there's one subshell, and it's only going to be the S. Okay, there's one subshell, it's going to be the S. In period 2, there's 2 subshells, and so there's going to be the S and the P. In period 3, there's 3 subshells. That means there's the S, the P, and the D. In period 4, there's 4 subshells. So there's the S, the P, the D, and the F. Okay, now I know there's more rows. There's 7 rows on the periodic table, but since there are various orbitals inside these, it takes more and more atoms to fill these, electrons to fill these. And so with our current periodic table, it doesn't go past F. All right, but do you see how easy? 1 has 1 subshell, row 2 has 2 subshells, row 3 has 3 subshells, row 4 has 4 subshells. So the only thing you have to remember is the order, S, P, D, and F. So you'll know if it's only 1, it's S, if it's 2, it's S and P, etc. Okay, so they give you the first one done. In shell 2, you've got the 2S and the 2P. Well, let's see if we're right. There's 2 shell in row 2, in period 2, there's 2 subshells, the S and the P, and it's named according to the row, to the period and the subshell. So you're going to have 2S and you're going to have 2P. It turns out that the S's are the first 2 columns and the P is the last 6 columns. All right. So how about 4? Well, 4, if you're going to do 4, it has to start with a 4. So the first one would be 4s. The next one would be what? A 4p. The third one would be a 4d. And the last one would be a 4f. Okay. What about in the first row? In the first row, there's one subshell only, so it's going to be the 1s, and that's all. So I hope you can do this, because I think you can.